So here, what we've got, we're doing a comparison of populations. We're identifying if we were to tweak certain things or change certain things up, what would happen if we do those changes, or comparing when we've got more than one population, so maybe more than one box and whisker plot or more than one dot plot. How is it changing, or how does it compare with those measures of center that we talked about and those measures of variability that we talked about? Remember, measures of center were mean, median, mode, and the measures of variation or variability was range and interquartile range. Okay, so for here, I've already stated that I've got 11 quiz scores from random students in the class. So I went ahead and plotted 11 students' quiz scores using a box and whisker plot. The only thing that I know is I know that one of the data points, or the smallest data point, is a 55, and the highest score somebody scored was a 95. It's the only thing I know. I also happen to know that one of my data points is an 80 because there was 11 different quizzes. So that means I had one center value, and that center value was an 80. So one of my data points also happens to be an 80, only because I had an odd number of data. If I had an even number of data, I wouldn't know whether that 80 was a data point, or was it when I added two values and divided by 2, I got 80. You know, that could have been, maybe I had a 75 and an 85, and when I add those together and divide by 2, I get 80, which means 80 wouldn't have been a data point. So I definitely know that I had a 55 and a 95, but I don't know what the rest of the values are, what the other 9 values are. I only know my highest and my lowest. But I do know that the spread of the data, I know what that looks like. And I do know that 50% of my students scored an 80 or higher. 50% scored an 80 or higher, because remember, starting at the median and going up, that represents 1/2 of your data set. 50% of them scored an 80 or higher, okay? So what I want to know is if we did a couple of different changes to the data, like if we manipulated the data a little bit. Let's say that I decide I'm going to be really, really nice to the upper half of my test scores, and I'm going to decide, hey, you guys did so well, I'm going to go ahead and increase your scores by 5%, and I'm not going to do anything to the lower half. So those of you who did not do so well, you're going to keep your score. Let's say that I decided to be unfair in that situation. So what would happen if I increased the upper half of the scores by 5%? I want to know, how is that going to have an effect? So again, if I'm increasing the upper half, that means there's going to be no change to what my minimum score was. My minimum score is still going to stay at a 55. My lower quartile is still going to stay at a 60. My median is still going to stay at an 80. What is going to change are my data points for my upper and my largest value. They are both going to increase by how much? 5%. So that means instead of it going to 85, it's now going to go to 90. And instead of my highest score being a 95, it's now going to go to 100. So then when I plot it, it's going to look something like this. So taking a look here, my span of my box and my upper half is bigger. The span going from my largest whisker has gone to a larger value. I've increased in certain situations and stayed the same in others. The only areas where I increased was the upper half of my data set, meaning this portion right here all increased by 5%. All of those values increased by 5%. So what we're seeing happen is that my minimum and my lower values are all going to stay the same. I want you guys to write this down. The minimum and your lower quartile remain the same. They had no change whatsoever. They were unaffected by my generosity. The upper quartile and the maximum increased by 5%. Those are the only ones that got affected. They are the only things that showed a change. That upper quartile value and that maximum value both moved up 5%. Okay, so because that moved by 5%, something else happened to change, and that's your variability. Looking up here at the original graph, who can tell me what is the range from my lowest to my highest? What is the range currently to go from lowest to highest? 40, right? To go from 55 to 95. Currently, my range in this case, if I take the 95 and I subtract the 55, my range is going to be equal to 40. And my interquartile range, my IQR, so to go from 60 to 85. So if I do 85 minus 60, my interquartile range is 25. That's what my original data has me showing. But now when I look at my new data, that's different. Okay? My variability has changed. It also increased. Okay? If we now look at what the range is, the range still started at 55, but now it spans up to 100. So instead of doing 95 minus 55, we're going to do 100 minus 55, and that goes to 45. So the range went up by 5 points. So does the interquartile range, the IQR. It's now going to be 90 minus 60, which is going to be 30. That's an increase by 5 points. So it increased by 5 as well. Both of these values are going to increase by 5. The median is completely unaffected. Okay, so by making those kinds of changes, by saying I'm going to increase one situation or one half by 5%, it expands that variability.
In the front, can I hear Lucy?
Sure, go ahead and sit where Azariah usually sits. Okay, now let's go back to the original data. What if instead we increase the lower half by 5% and then we decreased the upper half by 5%? Okay, so that means my lower quartiles from the original, my lower quartiles are going to increase by 5%, and my upper quartile and maximum are going to decrease by 5%. I want to see what kind of effect that has. So if my lower values increase by 5%, what is that going to bring my minimum to? What does my minimum now become if I'm increasing it by 5%? 60. Very good. What does the lower quartile become? 65. Okay. Is my median going to change? No, the median is not going to change whatsoever. Okay, so the median is still going to stay at an 80. What about now for my upper quartile and my maximum, we're going to lower those by 5%. So what is my upper quartile going to become if I lower it by 5%? 80. It also becomes an 80. And then what does the maximum become if I lower it? 90. So notice in a situation like this, your median and your upper quartile are now the same value. Your median and your upper quartile are now going to be the same exact value. So I'm going to make it a dark, dark line there. So that way I know this is also where my median is. It is also where my upper quartile is going to be. My median and my upper quartile are now the same thing. So how does that affect variability? What now happened to my graph? Take a look. Take a look at what the original range and interquartile range were for the graph and what changed. Did it change at all? Did it get bigger? Did it get smaller? It got smaller, right? If we take a look, the range in this case is now 90 minus 60. 90 minus 60 is going to give us 30. Okay, so this was a decrease. It decreased by 10. It was a decrease by 10. My interquartile range, my IQR, that's my box, is 80 minus the 65. 80 minus 65 is 15. That decreased by 10. So my variability kind of got smaller. The data points now become a little bit closer together, a little bit more squished in. Okay, so get that written down, and then we'll go on to the back. When you're ready, go ahead and flip it over to the back. Okay, so for questions like these, questions 3 through 5, what we're going to do is we're going to identify the mean and the median, and then we're going to graph it and identify symmetry for a box plot. So we'll graph the box plot together and then identify what the symmetry value is, or what the symmetry looks like. Is it symmetric, or is it skewed more to the left, or is it skewed more to the right? What I want you guys to do right now, though, is identify the mean and the median. You can identify the mean and the median for problems 3, 4, and 5. Everybody's identifying the mean and the median for problems 3, 4, and 5. Okay, let's go ahead and go over the means and medians for each of these problems real quickly. For problem number 3, to calculate the mean, remember you add all the values together. So we're going to add 1 plus 2 plus 2 plus 3 plus 4 plus 4 plus 5. We're going to add all that together, and then we're going to divide it by how much? Which is what? 7 numbers, right? We're going to divide it by how many numbers we have up here, which is 7 numbers. So we're going to divide this by 7. When we add all of this together, it gives us 21, and 21 divided by 7 is going to come out to 3. So the mean is equal to 3. The median, remember you have to place the numbers in order from least to greatest, which I already have them written in order from least to greatest. So 1, 2, 2, 3, 4, 4, and 5. And then all you've got to do is cross them off until you're left with a center value. So I'm going to cross off the 1 and the 5. I'm going to cross off a 2 and a 4. I'm going to cross off this 2 and this 4. And what am I left with in the center?
3.
A 3. So that means my median is 3. Now, I've already drawn a number line here, and I'm going to show you what your box and whisker plot will look like. You plot your smallest value and your largest value. Our smallest value is a 1, so I'm going to plot a 1. And my largest value is a 5. I'm going to plot a 5. There's my far ends. My median is a 3. So I know I'm going to have a section here for the 3. My first quartile happens to be a 2 because if I cover up my 3, this is my lower half of my data. This is the upper half of my data. And to find the quartiles, you just find the center of your lower, which is a 2, and the center of your higher, or your upper, which is a 4. So there's my first and my third quartiles. I have a 2 and a 4. So when I make my box and whisker plot, this is what it will look like. So now, based off of what I have drawn here, is this symmetric? Meaning, do you have an equal distribution on the lower half as you do on the upper half? Yes, right? It's a mirror image. It is a mirror image. Your lower half and your upper half are identical in their size. So we would say that this is symmetric data. This is symmetric. Okay, let's go ahead and work on problem 4. For problem 4, again, we need to calculate the mean. So the first thing that we need to do is add all of the numbers together. So we're going to add 1 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3 plus 4 plus 4. And then we're going to divide by how many numbers? How many numbers are there here? 9. So we're going to divide this answer by 9. When we add everything together, we're going to get 24. And then 24 divided by 9, you should have gotten 2.6 repeated. 2.6 repeated for our mean. Now, for the median, again, all the numbers are in order. It has to be in order from least to greatest. If you don't put it in order, you won't be able to find the median correctly. Okay, so cross them off. Once they're in order, cross them off end to end. You cross off each of the ends. So I'm going to cross off a 1 and a 4. I'm going to cross off a 2 and a 4. I'm going to cross off this 2 and this 3. I'm going to cross off this 2 and this 3. And I'm left with a 3 in the center. So my median is a 3. Okay, now if we graph this, my lowest number is a 1. My largest number is a 4. My median is a 3. God bless you. The median of my lower half is going to be a 2, so that's my first quartile. And then the median of my upper half, which will be my third quartile, is a 3.5. Okay, so when we are looking at the plot, is this symmetrical? No, right? The lower half is not the same mirror image to the upper half. This plot is not symmetrical. In fact, the lower half, it's skewed. We call it skewed more to the left. Your left half is longer or more spread out. So let's go ahead and write that down. This is not symmetrical. We also call that asymmetric. It is not symmetrical. Okay, the lower half is longer. It's skewed more to the left side. Okay? All right, let's take a look at our last one for problem number 5. Again, identifying the mean. We're going to add all the numbers together first. 2 plus 2 plus 3 plus 5 plus 5 plus 9 plus 10 plus 14 plus 15. And then we're going to divide all of this by what? How many numbers are there to divide it by? 9 numbers. Thank you, Vincent. There are 9 numbers to divide it by. So when we add all of this together, it gives us 65. And then 65 divided by 9 is 7.2 for the mean. Okay, median, again, you want to make sure all the numbers are in order, least to greatest. Always put them in order, least to greatest, and then you just cross them off as you go. We're going to cross off a 2 and a 15, a 2 and a 14, a 3 and a 10, a 5 and a 9. What's our middle number? A 5. Okay, our median is going to be 5. The median is going to be 5. Okay, and now we're going to graph what the box and whisker plot would look like. So for graphing our box and whisker plot, we know that this is the 5, that's our center. So here's our lower half. This is our lower half. This is our upper half. Okay, so first start with the smallest point and the largest point. We're going to graph a 2 for our smallest point and a 15 for our largest point. Make sure you're getting this graphed. Then we graph our median. Our median is at the 5. Then we graph the center of our lower half. The center of our lower half is between the 2 and the 3, which is 2.5.
Can I get a pencil?
They're in there. Then you graph the center of your upper half. The center between the 10 and the 14 is a 12. Did you get one, Ezra? He was opening them up for you right there, babe. Okay, and then we connect. We build our box. And then our whiskers. Daniel, turn around. Okay, now taking a look at it. Is this symmetrical? Esther, is this graph symmetrical? No. Okay, it's longer on the right side. The right side is more expanded. So again, this is not symmetrical. Okay, the upper half. The upper half is longer. So what I want for you guys to take a moment and think is, if you look at the next question, question number 6, what do you notice occurs with mean and median in relation to symmetry? So I want you to take a look at what the means and the medians were and the symmetry, and what do you think a rule is that you could come up with. So if we're looking here for problem 3, the mean and the median were the same and it was symmetrical. For problem 4, the mean and the median were not the same and it's not symmetrical. And for problem 5, the mean and the median are not the same and it's not symmetrical. What do you think you can hypothesize? If I were to just show you a box and whisker plot, what would you know about mean and median?
That's French-Zheng.
Yes. All right, what do you think that you can hypothesize when we are talking about mean and median What do we know about mean and median and how it would relate to the symmetry based off of these 3 examples? Anybody think that they can come up with something? What do you think, Michael?
The mean and the median are the same, the symmetry will not be symmetrical.
Okay, so he says if the mean and the median are not the same, then they are not going to be symmetrical. So what he said is that if the mean and the median are not the same, you're not going to have symmetric data. So that means if the mean and the median are the same, your data is going to be symmetrical. So we want to make sure that we get that as an understanding. Okay, so write this information down. This is really important for you guys to know. When the plot is symmetric, your mean and your median will be the same. If your plot is symmetric, meaning that they are mirror images on left and right, then that means that you're going to have identical means and medians. Because guys, if I just give you a box and whisker plot, you don't know what the mean is. In order to know the mean, you have to know the data. So if you're given a box and whisker plot, you really don't know what the mean equals. But if you look at its symmetry, you can get an idea of what it would equal. So if it's symmetric and you know what the median is, then you would know what the mean is. The mean and the median are the same. If it's not symmetrical, here's the big part. If your plot is not symmetrical, then your mean is either going to be bigger or smaller than your median, depending on how the box and whisker plot looks. So if your box and whisker plot is longer on the left, then your mean is going to be smaller than your median. If your box and whisker plot is longer on the right, then your mean is going to be bigger than your median. Okay? So longer to the right means longer upper half means a larger mean. Longer to the left, meaning longer lower half, means a smaller mean. So let's get that part written down. If the plot is not symmetric, then the mean is going to be less than the median. Mean will be less than median if the lower half is longer. Or mean is going to be greater than the median if the upper half is longer. Okay? So again, if it's not symmetric, then either the mean is bigger or the mean is smaller. If the mean is smaller, it's because you have a longer spread in the lower portion of your data. If the mean is bigger than the median, it means it's because your upper half is a longer spread. So you might not know exactly what the mean is going to be, but you do know whether it's going to be bigger or smaller than the median. And if it's symmetric, you know it would be equal to the median. Okay, let's take a look at a few things that we want to do some comparisons on. So if we've got, two different populations of heights. So we've got two different sports teams. We've got the New York Knicks and we've got the New Jersey Nets. Okay, and we're going to compare the heights in inches of the players. So are there only 5 players on the whole entire team of the New York Knicks? No. But these are the 5 data points that we're plotting based off of the information we've got from all the players. Okay, so again, these are just representations of the overall group. This is not the only amounts that exist. We do know, though, that the smallest height for a New York Knicks is going to be what? What's the smallest height of the New York Knicks players? 74. What's the tallest height on the New York Knicks? 83. New York Knicks. Okay, the Knicks, 83. What's the shortest height for one of the Nets? 72. And what's the tallest height? 84. So we do know the shortest person on the team and the tallest person on the team. That information we do know. So that's important to make sure we understand. Now, we want to answer a few questions based off of these plots. I want to know, what is the difference between the medians? The difference between the medians. Now remember, the median is found inside of the box. So what is the median for the Knicks? What is the median value for the Knicks? 80. Good. Our median value is located right here. That's the median for the Knicks. So I'm going to write that down, that the Knicks has a median of an 80. What about for the Nets? What's the median height of the Nets? 79. The median height of the Nets is going to be 79. Now the question wants to know, what is the difference between the heights for the medians? What does that mean if I'm talking about difference? Who can raise their hand and tell me what operation is difference? Abdullah. Subtraction. So all we're going to do is subtract these two values. We're going to take 80 and we're going to subtract 79. And what is that going to give us? 1. So the difference between their median heights is a value of 1. All right. The interquartile range. I want to know, what's the interquartile range for both teams. Remember, interquartile range is the box. Interquartile range is the size of the box. So if I'm talking about interquartile range, I'm talking about how big the box is. So how big is the box for the net or the Knicks? It starts at 76 and it ends at 81. So that's a what? 5. Okay. Starts at 76 and ends at 81. So all I'm going to do is take 81 and subtract 76. That's going to come out to 5. So there is the interquartile range for the Knicks. Now we want to do the same thing for the Nets. Okay. So I want to know, what is their box size? How big is their box going to be? So starting at 75 and ending at 82. What is 82 minus 75? 7. Okay, so who has a larger interquartile range? The Nets. Okay, the Nets have a larger interquartile range. Now, take a look at this word, consistent. Remember, we talked about consistency before. When we talk about consistent, we're talking about values that are closer together. So if we're saying more consistent, off to the side, write this down, more consistent means smaller range and interquartile range. If we're talking about things being more consistent, that means it's not spread out. You don't have a large spread. So that means you have a smaller, more compact data set. The numbers are closer together. So more consistent means smaller range and interquartile range. Okay? Less consistent is the opposite. If it's less consistent, then that means you're going to have a bigger range and interquartile range. because your data is going to be more spread out, less consistency. Remember, we talked about that before, that if I've got a student who scores a 92 and then a 78 and then a 51 and then a 85 and then a 14, I don't have a good idea of how they're going to do because their data is all over the place. But if I have a student who is scoring a 64 and a 71 and a 68 and a 70, then I have a better idea of how they're going to do because their data is more compact together. Okay, they're not spread all over the place. So more consistent is a smaller range. Less consistent is a bigger range or interquartile range. So here we're looking for more consistent. I already know what the interquartile range is. So now let me go ahead and take a look at what the actual range values are going to be. Remember, range is the entire spread of the data set, starting at your smallest and going to your largest. That's what we mean by range, starting at your smallest value and going up to your largest value. So for the NICS range, we started at 74 and went to 83. So 83 minus 74 is going to equal 9. And then if we look at the NETS range, it starts at 72 and goes to 84. So we're going to do 84 minus 72, and that's going to come out to 12. So who's more consistent? Who has a smaller range and interquartile range? The NICS. Okay? NICS are more consistent. The NICS are going to be more consistent because they have a smaller range and a smaller interquartile range. That means that their data set is more compact. And if you look at it, you can just look at it. Look how more closely compact it is than the NETS. The NETS has a bigger spread of data, not very consistent. Okay, get that down. Go ahead and turn it over to the back. Problem 8. You're going to answer the questions based off of this dot plot. It's not a box and whisker plot anymore. It's a dot plot. So you're going to tell me, here's Lily's information. Here's Alessandra's information. Is Lily's data symmetrical? Is Alessandra's data symmetrical? So that's a yes or no. Are they symmetrical or not? What are the medians for both of the girls? And what are the means for both of the girls? Okay? And remember what we said about symmetry. If it is symmetrical, mean and median will be the same. If it is not symmetrical, then you need to look at how it's spread. Is it more spread to the left? That would mean mean is smaller. Is it more spread to the right? That means mean would be bigger. Okay, let's go over this. For the first plot, Lily's plot, is Lily's plot symmetrical? Yes or no? Yes, right? It does follow a perfect curve. So this is symmetrical. It follows a nice perfect curve with an even distribution on the left side as it does on the right side. So Lily is symmetrical or symmetric. We'll just say symmetric. What about Alessandra's? Is Alessandra's symmetrical? Yes, hers is symmetrical as well. So both of them have symmetrical data. Alessandra is symmetrical. So then what does that mean about their means and medians? They're the same. Mean and median are going to be the same. So I don't even have to sit there and calculate the mean. I can just do the easiest thing, which is to find the center point. Finding the center point is so much faster. If I look at Lily, I'm going to cross off the first and last, then cross off the next point and the next point, and the next point and the next point, and then the next point and the next point. And what's my median? 60. My median is going to be 60. So Lily is going to equal 60. What is Alessandra is going to equal? 50. Again, cross off the first and the last. Cross it off, and you keep crossing off until you're left with a center point. So Alessandra's is 50. And since we know it's symmetrical, that means that this Lily's mean is 60 and hey, stop packing up. Stop. Lily is 60, Alessandra is 50. They are identical to their medians. Tomorrow, you are going to have a quizzes on comparing populations. Now you may pack up.